Welcome to the physics class, BSc Physics, third semester, paper name Geometrical and Physical Optics, Electricity 1 and Basic Electronics. In this paper, third unit, Theory of Dielectrics and Moving Coil Galvanometer. In the session 9, we learnt about the derivation of the Clausius-Mossetti equation and its limitations. So first we see that what is meant by Clausius-Mossetti relation, how it can be derived. So here we considering as in two parallel plates of the capacitor, two parallel plates of the consider now you see in the diagram two parallel plates of the capacitors will be obtained, and this it can be placed into a dielectric material. Applied electric field between these two charged capacitor, it will be obtained and polarization will be obtained. The alignment of the positive ions are moving into positive charge are into the negative charged capacitor plate, and negative charges will be positive charged capacitor. Induced charge will be formed, and due to this dipole moment will be obtained and the electric field will be obtained into the opposite direction. So this is familiar. In previous classes already we studied about this concept. So consider a dielectric material in which has predominantly been the electronic polarization. Other effects are negligible. Other effects are is small and minute values. The dipole moment or electrical polarization will be large effect. In dielectric materials, the dipole moment of the and the electronic polarization are given by mu e is the dipole moment. In some textbooks, small pii, which is represented by an induced dipole moment, which is also equals to mu e, that is equals to alpha e into E. Here alpha E is the electronic polarizability of the medium. Let n be the number of molecules per unit volume, alpha E be the molecular polarizability. Then total polarization is equal to P is equal to n into mu. N is the number of atoms per unit volume and mu is the dipole moment. Here Pe, polarization due to electric field, that is replaced by an n into mu e. Mu e is the dipole moment of an electron. Mu e is replaced by an alpha e into EL. EL is the localized electric field. EL is the localized electric field. Here we knowing about n is the number of atoms per unit volume. We know that D is equals to epsilon into E. This is the relationship between electric displacement vector and the electric field intensity E. Already in the previous class we learnt about a relationship between D, E and P is D is equal to epsilon naught E plus P. Rearrange this equation, P becomes epsilon naught D minus epsilon naught into E. Here both the sides dividing by capital E, we will get P by E is equals to D by E minus epsilon naught. Next, D is equal to epsilon into E. We knowing about that epsilon is equal to epsilon naught into epsilon r is replaced by this equation. Due to this equation, D by E is equal to epsilon r into epsilon naught. Thus the above equation will be becomes P by E is equal to D by E is replaced by an epsilon r epsilon naught minus epsilon naught. In the right hand side, both the term epsilon naught will be common. We will get P by E is equal to epsilon naught into epsilon r minus 1. Next, P is equal to epsilon naught into epsilon r minus 1 E. E will be coming to the right hand side. This will be called as an equation 2. The localized electric field in equation 1, we will get EL is equal to, we knowing about that EL is equal to E plus P by 3 epsilon naught. Therefore, this value is substituting into the equation 1, we will get P is equals to N alpha E. EL will be replaced by E plus 3 dividing by E plus P dividing by 3 epsilon naught. Next, N alpha E. So equation 2 and 4, left hand side will be same, therefore right hand side will be equating. We will get N alpha into E plus P dividing by 3 epsilon naught is equals to epsilon naught plus epsilon r minus 1 into E. Next, n alpha E will be multiplied on the inside of the bracket. We will get n alpha into E plus n alpha into P dividing by 3 epsilon naught, which is equal to right hand side will be same. Therefore, substituting the P value in the above equation 2. P value is will knowing about epsilon naught into epsilon r minus 1. Will be substituting this equation into E. In this equation, we will taking common on the n alpha into E will be common. We will getting 1 plus epsilon naught into epsilon r minus 1 dividing by 3 epsilon naught 1, which is equals to this term. In the both side, E and E will be gets cancelled. Next, we will get n alpha A dividing by 3 epsilon will be taking right side. Therefore, LCM is 3 epsilon naught. Here numerator will be multiplied by 3 epsilon naught plus epsilon into epsilon r minus 1 and epsilon naught into epsilon r minus 1. Therefore, this will be multiplied on this equation. We will get minus epsilon naught. 3 epsilon naught will be subtracted by an epsilon naught. We will get 2 epsilon naught. Epsilon will be taking outside. Epsilon naught and epsilon naught cancelled. Finally, we will rearrange this equation. We will get epsilon r minus 1 dividing by epsilon r plus 2, which is equals to n alpha E dividing by 3 epsilon naught. This equation is known as a Clausius-Mosati equation, and it holds for good crystals having high degree of symmetry. This equation is related to the dielectric constant epsilon r, which is macroscopic property of the dielectric medium, to n alpha E, that is electronic polarizability, which is atomic property of the material. Therefore, what are the limitations of this Clausius-Mosati equations is Clausius-Mosati equations relates to the macroscopic dielectric constant of the material to the microscopic polarizability of its constituent molecules. It describes the behavior of dielectrics in an electric field. This Clausius-Mosati equation will be assumes the polarization is proportional to electric field. Dielectric is polarized by the uniform field, like between the capacitor plates. Molecules are in isotropic, short-range interactions are absent. These conditions are typically met by a neutral, nonpolar molecule and are applicable to the liquids and gases, but not applicable to the strong solution and the solutes. Thanks for watching. Today's class we learnt about Clausius-Mosati relations and its limitations. Thank you.